This video covers Cheyney's homework for week 5 of RP1. We're going to go through one example on each night. We'll start with Monday. On Monday night's homework, you have first a review question that we've been practicing a lot in class, which is just to make sure that we can use inverse operations to find the missing number in a multiplication sentence. I'll actually demo one of these. If I know the product, and remember the product is the answer to a multiplication question, is 31.5, I can divide my product, the answer, by the factor that I know, so in this case that's 21, in order to locate or to calculate the missing factor. So 31.5 divided by 21 gives me 1.5, and since that is the quotient, the answer to my division sentence, I know it's also the missing number, and I can double check that in my calculator. 21 times 1.5 does get me to 31.5. So I know I've got the correct answer in my blank. We'll look at one more example from Wednesday to check out these double number line problems, which is the main focus of the assignment. In question 3, you're being asked to use a double number line to answer the following questions. The first thing you need to do is write two ratios. I'll leave that to you, but just give you a reminder to pay close attention to what's being compared and that the format of a ratio looks like this. When we're looking at question C and being asked to annotate to find the magic number, we're being asked to figure out 5 times what equals 6, 10 times what equals 12, and 15 times what equals 18. I chose to move this way through my double number line just because tickets is a smaller number than price. You also could have chosen to multiply 6 times something to get 5. It would just be a trickier decimal, but that's totally allowed. Remember that if I'm trying to figure out 5 times blank equals 6, I have this great division strategy that I modeled here to find the missing factor. And once you have the magic number, you'll have all the information you need to answer question D. We'll look at Tuesday next. On Tuesday's homework, we're practicing working in ratio tables and using ratio tables to write equations. We'll use question 2 as our example. Question 2 says, the producer of a news station posted an article about the high school's football championship ceremony on a new website. The website had 500 views after 4 hours. And I actually put that in a table for you, 4 hours, 500 views. So, like most tables, we want to start by finding that magic number. What are we multiplying hours by to get views? I'm going to do it over here on the side because I know that 4 times something equals 500. So the same strategy I demoed on Monday, I can divide 500, which is the product, the answer, by 4, which is the factor I know. And that will give me the missing factor. So 500 divided by 4 is 125. And once I have that magic number, it gets really simple for me to fill in my table because I'm just multiplying hours by 125 over and over again. Now, of course, you could also think of these as simply equivalent ratios where you're multiplying 1 times 2 to get 2, and 125 times 2 to get 250, and then 125 times 3, and 125 times 3. I'm sorry, I should say 1 times 3, and then 125 times 3. I think that multiplying across the table starts to get a bit simpler, but we do want to remember that all these ratios are in fact equivalent. That magic number has broader importance, though, which is that it allows us to write an equation, which remember is just our roadmap for how we're working across the table. Our equation is what do we always do to t time to get v views. And in our table, we can see that we're always multiplying time by that magic number of 125. all that this here says is if I multiply time by 125, I will get the number of views. And that's the same every time, no matter how many views there are, no matter how much time there is, all the ratios are equivalent, and so the pattern stays the same. We'll look at Wednesday next. Wednesday night's homework is similar to Tuesday. You're working more in tables to find relationships and equations. We're going to use question 2 again as our example. In question 2, Maya is making personal pizzas, and for 4 pizzas, she uses 10 ounces of cheese. They want us to complete the ratio table and include a row that shows how much cheese she'll use for 1 pizza. So I'm going to start with 4 pizzas, 10 ounces of cheese, and I'll just do my skip counting. You can finish that on your own. Just remember that we are going to need a row that includes 1 because they did explicitly give that direction. Include a row that shows how much cheese she'll use for 1 pizza. And where you'll want to start is just by finding the magic number. 4 times what equals 10 and 8 times what equals 20. And of course, at this point in the video, we've talked a lot about how we can use division to find that missing magic number once the table gets a little tricky. But what I want you to realize here is that once you find the magic number, you have everything you need to write the relationship or the equation. Because you know what you're multiplying P by every single time to get C. What I want to challenge you to do in question B is to also show me what can you do to C every single time to get P. And on this Wednesday night homework, I want you to really push to include both of those equations, the multiplication and the division. All right, let's take a look at Thursday night's homework, our final night. This homework covers the topic that we all got to review in our small groups this week, which is just some basic fraction comparison. And we'll look at question 2 as our example. Question 2 says, plot the following points on the number line without measuring. And without measuring, it just means we're looking for kind of an estimate. For example, how does 8/10 compare to 1/2 and 1? And I mean, we know that 8/10 is less than 1 because it's less than 10/10. But we want to see how 8/10 compares to 1/2. And one way we can do that is by drawing a diagram. So I'm going to start by just showing a sketch of what 1/2 is. Obviously, it's just half of my tape diagram. And then I'm just going to go ahead and sketch what 8/10 would look like. And to do that, I'm going to split my diagram into tenths, so literally 10 pieces. And I'm going to sketch 8 of them. I think it would have been better if I had done my 1/2 on this side, so let me fix that. 1/2. And then 8/10. 1, 2, 3, 4, 5, 6, 7, 8. So I can see that 8/10 is definitely bigger than 1/2. It's a bit closer to 1 actually, because if you imagine this right here as 1 whole, it's even closer to 1 whole than it is to this point, which would be 1/2. And once I do 8/10, I want to kind of repeat the same steps with 3/5. I could draw my diagram again, right? I could even take this one and just adjust it. Since I'm on my iPad, you'd have to do it by hands. But I could divide into fifths and color in 3 of them. And I'd be able to see just from the picture that 3/5 is less than 8/10. It's obviously more than 1/2 because 1/2 would be right about here. And so I know that I'm going to put 3/5 somewhere between 1/2 and 8/10. Another thing though that I could do to compare 3/5 and 8/10 is I could actually create an equivalent fraction and say, well, 3/5 is the same thing as how many tenths? I know that 5 times 2 is 10 and 3 times 2 is 6. And so I know 3/5 is equal to 6/10. Well, 6/10 is obviously less than 8/10, and so this makes sense that 6/10 would be less than 8/10, but more than 1/2. And that's what I'm asking you to do. I want to see your work. I want to see what you're thinking, but I'm not looking for any sort of perfect comparison or perfect fractions math, just for evidence that you're really breaking down the fractions and thinking about why a fraction like 3/5 fits wherever you choose to put it on the number line. And that's Thursday's homework. As always, if you have questions, please make sure you are checking in with Miss Kinez before the end of the week.